waiting for the countdown. All right, here we go. So we are going to be looking at something called a draw loop. So hopefully at this time, everybody has been caught up to Unit 3, Lesson 10, which was the mini project, where we created an animated scene with some text. That was pretty much the crux of what we were doing all of last week. Hopefully you had a chance to work on it on either Wednesday, Thursday, or Friday when we did not have class officially. But again, we are working on something called the draw loop. All right. So we're going to go ahead and take a look at that. Give me one moment because my computer is super slow.
Animated movies create the impression that characters are moving smoothly, but if you slow them down enough, you'll realize there are lots of individual images. Each image is just a little bit different from the one before. Speed them back up, and your eyes are tricked into thinking you're watching real-life motion. A very simple example of this effect is a flipbook. The key to animation, whether on paper or the computer, is that part of the drawing is changing over time. An easy way to achieve a change is to use the random number command to generate a new random location, size, or color for the shape we're drawing. Here's a simple program that draws a single rectangle with a random X position and a random Y position. If we run and reset this program over and over again, we can see that it draws the rectangle in a new position each time. But that's like a flipbook with only one page. To create real animations, we need to be able to string these pages of the flipbook together. In GameLab, we'll do this using the draw function. The draw function is special in GameLab. The commands inside of the draw function are run line by line from top to bottom. But once the computer reaches the end of the commands inside the draw function, it jumps back to the beginning and repeats the commands over and over again, as long as your program is running. Because the code in the draw function repeats in a loop, we'll just refer to this as the draw loop. Let's move our rectangle inside the draw loop and see what happens. Whoa, so many rectangles! We can see that a rectangle isn't just being drawn once anymore. GameLab is automatically calling the commands inside of the draw loop many times a second. In this program, that means that a new random X and Y location is generated, and then a rectangle is drawn over and over and over. You can place as many commands as you like inside of the draw function. For example, let's choose a new fill color before drawing each rectangle by placing a fill command inside the draw loop. Instead of always choosing the same color, we'll randomize by replacing the red value with the random number command. So in every frame of the flipbook, the computer is picking a new shade of red and setting that as the fill color. Then it picks a new X and Y value and draws a rectangle with those values. In a typical animated movie or flipbook, you don't continue to see all of the drawings that came earlier in the animation. Instead, you have the illusion of a single shape or character moving over time. You'll discover how to make that happen with the draw loop soon.
All right, so I hope that you see where we're going with this. Again, this is our animation/game unit. So at this time, all we've really done is we've created static images. What we want to be able to do is create images that then can move. Okay? So again, once you're done with that, make sure you go ahead and hit continue. Now, as you can see, some of my loops have already been done. I will just have to go ahead and reset these. Okay, so it says draw loop. Here's an example of how a draw loop would work. Run the code and see how it works. Discuss with the partner whether this looks like the flipbook that you saw in the video, why or why not. All right, so again, I like to make this a little bit larger, and I like to get rid of my instructions just because that's how I like to function. All right, so what do we see happening here, guys? Is it a smooth animation, or does it just keep drawing itself over and over and over again? Anybody? And if I reset and run
It's
it,
not a smooth animation.
yeah, it's not a smooth animation. Like basically, what we're getting is we're getting all these Again, we can see that it's a random X location, a random Y location for this sea green colored ellipse, and that's fine. Except for that's not normally how animations work, and we need to see if we can figure out how to do that eventually. All right, so that's it. This is just kind of like a take a look at it. So we're gonna go ahead and hit finish on that. All right, so now it says it is your turn to do some work with the draw loop. Remember, the code inside the draw loop runs in the game lab over and over again. So again, just like we've talked about before, computers will read your code from line 1 all the way down to line 9. What I want to point out is 4 through 7 is now inside of a draw loop. What that means is, as long as this program is running, it will read 4 through 7, and then it will jump back up to 4, and then it'll go 4 through 7, and then it's going to jump back up to 4, 4 through 7, jump back up. It is going to keep reading whatever's inside the draw loop over and over and over again as long as the program is running. Okay, do this. Add code to the program so that your drawing has orange circles being drawn too. I need to go back to my version, start over. Forgot to do that, but that's okay. I'm like, it already will. Okay, so if I go ahead and run the program, this is the program that we just looked at, okay? And I'm just getting my green circles. So I want to have randomly generating orange circles as well. So I'm going to go ahead and reset that, and I'm going to take a look. So I have orange and green circles. How do I do this? So again, I already have a draw loop, okay? So I'm going to need to bring in another ellipse, and the fill color for that ellipse is going to have to be orange, which isn't a choice, so I just have to type it. And as far as to create random, I'm going to go into my math drawer. Now remember, these drawers are color coded. So if I see something in orange, I just know that it has to be in my math drawer, which is also orange. So I'm going to go ahead and go into my math drawer. I'm going to get random number. I'm going to generate a random X location, a random Y location. Now remember, my grid is 0 to 400, so that's the range I'm going to put on it. Just like above. Okay. So now I have a randomly generated green circle, a randomly generated orange circle, which I spelled wrong. Can't talk and write at the same time, but that's okay. So again, this is going to be inside my draw loop because again, I am going to constantly be creating these random green and orange circles. Go ahead and hit run, and that's exactly what ends up happening. Now, is it going to look exactly like the one over here? Probably not, because again, there's that random feature. But once again, what we see is that inside the draw loop, as the program is running, it keeps going back and making more green circles, more orange circles. And again, it's just filling up the screen, which is fine, because that's what we need to work on for at this moment. Okay? Once you have done that, I'm going to go ahead and hit reset. Go ahead and make sure you hit finish. That will send it to my teacher side. I'm going to have to reset this because it looks like I already did bubble 4 with my class last semester, but it's okay. All All right, cool. This one's just a prediction, so I can't reset it, but that's all right. It says this program has one small difference that will make it run entirely differently. Again, remember, all code outside of the draw loop runs first, only one time. All code inside of the draw loop is run over and over and over again forever. What will this program do? Write your prediction below. So, my prediction was it's going to draw something red. Okay, so it has no stroke, background yellow, I'm sorry, background blue, fill of yellow, background red, ellipse, random number, random number. What do we think is going to happen here? Look at the draw loop inside, or look at what's inside the draw loop and make a prediction. And once you make a prediction, type it into your thing. Please, somebody tell me what their prediction is. What do we think is going to happen here, guys? It's going to show the background blue and then fill it in yellow. Okay, maybe. I don't know. Let's go ahead and hit run on this. But thank you for participating. I appreciate you. All right. So, how is this different than what we've been looking at, guys? How is this different than bubbles 2 and 3? In bubbles 2 and 3, did we only get like the one circle being drawn? Because what you'll notice here is that I'm only seeing one circle at a time, right? And the reason for that is because I added my background into the draw loop. So I draw a new background and a new circle, new background, new circle, new background, new circle. It's not that those other circles aren't there, it's that they're being covered up. This is one of those things that we're going to have to do, putting a background inside the draw loop, which is going to help us create smoother animation. So in this case, I'm not seeing hundreds of circles pop up. I'm just seeing one at a time, which is a lot closer to actual animation that we are used to. Okay, so again, this bubble number 4 was just a prediction. Once you have your prediction and you've run your code and you've taken a look at it, make sure you go ahead and hit finish so it gets sent over to me. Okay, sprites inside the draw loop. By changing sprite properties in the draw loop, you can animate your characters. Run the code, see how it works, and discuss with your partner why some code inside the draw loop and some is outside of the draw loop. Try changing the numbers for the random numbers and number block and running the program again. Okay, so I'm going to go ahead and hit run. And what I now see is this little alien dancing. So let's take a look at the code. First, I create the sprite. Okay. And then I set the sprite's animation to this green alien. Why would I create the sprite and set the animation outside of the draw loop? Does anybody have a guess? Anybody? Why is the variable and the sprite being created outside of the draw loop? Yeah, thank you. Okay, it's in the chat. Because we really only needed to create the sprite one time. It is the motion of the sprite that we wanted to have in terms of inside the draw loop. So we can see the background is the first thing. That way we're not getting a bunch of like the shadow images. And then I have rotation because all he's doing is rotating slightly forward and backwards randomly. And then the draw sprite is also inside of the draw loop. Okay, cool. Then it asks us to change some of the numbers. So I'm going to go ahead and hit reset. And I'm going to change this to -20, +20 for my rotation. And you can see he's rotating more. If I change these numbers and made them even bigger, let's go -90 to +90, he's going to rotate even more. Okay? This is a very simple way of creating the illusion of motion. okay? Because all I did was create a random rotation for my sprite, and it's inside of the draw loop, okay? By doing this, it gives the illusion that the little alien dude is spinning, okay? So once you do that, go ahead and hit finish, and finish, and continue. And then we now have bubble number 6, which is the last one I think I'm doing with you guys. I think 7, 8 are your guys's, and then 9 is the challenge, so it's going to be optional. Okay. So it says, do this. The animation is already updating one of the sprite's X properties to make it look like it's shaking. Run the property to see how it works. Edit the code in the program to make the second sprite shake like the first one. Move on when your program looks like the one on the right. So I have a pencil and a paintbrush, which are shaking. Okay, so I'm going to go ahead and get rid of my instructions, make this slightly bigger. Okay, so when I go ahead and run this, I can see my pencil looks like it's moving, but the paintbrush does not. So looking at the code, can somebody tell me why my brush is not moving? What is different from the pencil code versus the brush code inside of our draw loop? Anybody? Yes. So the brush is only being drawn at one location. The X location is not changing at all. All right. So if I want that to happen, I'm going to go ahead and hit reset on this. And I go into, okay, that's fine. I'm going to go ahead and go into my math. I'm going to pull in a random number. And it was set at 300. So I'm going to go from 300 to 310. Just because that's kind of similar to what's going on up here at the X location. It's going from 100 to 110. The original number here was 300, so I'm going to say 300 to 310. Once I hit run on that, again, I have the background inside the draw loop first. I have whatever animation I want to have happening second. And then the last thing is always going to be draw sprites. Notice your variables and your sprites are created outside of the draw loop. Go ahead and hit run. Once I do that, ladies and gentlemen, I can now see my little paintbrush also moving, just like the pencil. Okay? So that is how we do that. Again, in the draw loop, anything inside the draw loop gets done over and over and over again. So you are going to create your variables and your sprites and set your animation outside of the draw loop. Make sure that the first line inside your draw loop is your background. That way you won't get that shadow image. The last thing inside your draw loop should be the drawing of the sprites, and then whatever else in between in terms of the motion that you are going to be creating. Once that's done, go ahead and hit finish. All right, bubble number 8, ladies and gentlemen. This is your practice. You have A, B, C, and D. We are updating rotation. We are debugging a blurry sprite. We are debugging repeated animation. And we are debugging the sprite not being able to move. So that is your bubble 7. You will go into A, B, C, and D and make corrections to the code so that it works properly. Bubble number 8. Again, you have this image over here of a salt shaker. And then when I run the code, it's just kind of standing still. So I need to make this, my image, do what's being happening in the screen in the example. And then on bubble number 9, which are the challenges, again, totally optional. Feel free to play with it, don't play with it. But you are required to do 7, A, B, C, and D. You are required to do 8, which is the salt shaker animation. And then once you are done with that, you have completed lesson 11. So I'm going to go ahead and stop the video. I will post the video as soon as it renders, and the rest of the time is for you all to work with. Please go ahead and get started.